Hey, so this is going to be a bit of a different video. I want to do a prototype of an entire project in one take, kind of just speed run through the most basic parts. Something I'm not super sure on how to do. So you'll be able to see my process. So the project is called, very uninspiringly, Struct. That is too big. To types. So basically what I want to do is I want to take Go code, like structs, types basically, and I want to turn them into some TypeScript stuff, but not just any TypeScript types, right? I want to turn them into maybe some Valibot stuff. So these are validators, or some Zod. I think that's the most common, but Zod is quite big on the web, so maybe wouldn't use that. I was looking at Valibot because it's quite a small library. Alright, could make your own. But basically that would be the two parts, the parsing of Go structs, and kind of the AST walking part, and then the output. So there's you take the AST, that is Go code, and then you can build some intermediate and then go off to the final output, the output. So it's kind of like a compiler, but maybe not as complex as a regular one. From the very little research I've done, which isn't a lot, this stuff probably exists, but I wanted to, whoops, that just fell. I wanted to do it myself. So, all right, what I want to do is I want to write a parse.go, parse.test.go, no, is it parse_test.go, package main, func, let's see, parse, and it returns a string, return hello, and here we go, func, test, parse, that takes in t, which is of type testing. Oh, it needs a package, doesn't it? Package main testing.t. Output parse, which is parse. Let's see, if output parse is equal to this, then we go t.fail now, for example, and just go test dot / I think it is. Yeah, so there we go. We have some Go files, and we have some testing. There's some documentation to look at. Golang parser. There's the standard library for Go parsing, which is probably what I'd use. And okay, so something very, very simple that I would want to look at. Sorry, the architecture that I kind of want is you point to a file or some, actually, yeah, we can point to a string and then output more string, right? So in the middle you'd parse stuff. So let's see our parse function that takes in some Go code, which is a string, and it would output a string. Okay, so this would be oh no, look at the comment automatically here. Takes Golang code as input and outputs the correct parsing code for Valibot. We can obviously make this a little bit more modular in the future. So let's do this in a test-driven way. So simple struct. Okay, so it's going to be a multi-line struct, and just so I get it right, struct. What is it? Oh no, it's type, isn't it? So it's type. Simple struct. That's going to have hello string. It's just a very simple struct. Let's copy that, put it here. Yeah, like this is good. Okay. Simple struct. And not quite sure what I want to output, to be fair. Can't quite remember what the Valibot stuff is. Maybe I'll try something. cd learning, cd make dir testing Valibot pinit pi Valibot v-index.ts. Oh wait, where am I? That's not it. Oh wait, hold on. Remove package JSON, remove node module, cd, node module, cd, testing Valibot, p init. P is just shortcut for pnpm, by the way, if you're curious. Oh, actually. We can actually do bun in it, I think. This is nice because then we get instantly we get some types. I don't really want to run any code, but I do want the autocomplete. So here we can go bun install Valibot. Oh, that's so good, it's just instant. Great, so import all as v from Valibot v dot object. Really we don't want to use these, we want to use ES modules so that we get tree shaking on the other end. Const my struct parser, I don't know what to call it. Object is going to have hello and it's going to be string on Valibot. And then struct parser dot, actually yeah, this is literally just what I want. So the output would be something like this. Type Valibot parser. Is it a parser or validator? I think it's cool. It's a validator more. Validator. Valibot validator. Yeah, I think so. Do we keep the H low or bit? Let's keep it this consistent like that. If output parser is not equal to Valibot validator, then t dot fail. Fail now. There you go. And if we run this, it will fail. Good. So we have our test. Now we have to do the actual hard bits. I don't have a debugger, but I kind of love one right now. Anyways, let's do something with parser. No, surely not. Parser dot parse. For obtaining IC of an expression x. Yeah. Is there an expression? I'm not sure what counts as an expression, but I don't think everything would count as an expression. What is an AST file? Golang expression. You know, it would be great to look at GitHub Golang, and we can actually look at the code there. So hopefully they have some test cases. So they go programming language, great. Where would this even be? Source? Parser? Yeah, great. Parser.go parse expression Maybe some test cases. There's parse file. Yeah, parse file here. Parse expression. I have no idea what that is. Maybe we want to parse a file. Maybe we do want to do parse file. I want to go into this because I don't know what token dot. What's a file set? Protects the file set. Base offset for the next file. Oh, what are you? Parse file. Token. Dot new file set. I have no idea what you are. If I do parse file token dot new file creates a new file set, file name. If we don't give a name and we give a source, 0. I'm kind of just copying this, seeing what that does. Parsed file error, so we return string or error. If error is not nil, return this and the error. Parsed file dot comments import. Oh. That's pretty nice. Yeah, we have lots of stuff. We have associated documentation, the name, the scope, apparently that's deprecated, the end, imports, package, comments, file start, go version. What do they have here? Decls. Top level declarations. Oh. Maybe I can print that. Let's print you. Yeah. It's gonna be error. If error is not equal to null, then we do t.fail now. T.log. Log. Yeah. Error is not null. And we do t.log error. Okay. Error is not null. Expected package file type. Oh, yes. So this is going to be package types like this. So that's now valid go. Declarations dot end position of first character on the end. What are right declarations? It's an interface node that has position declar node. Oh yes. Oh, we have to cast this. Oh yes, I remember seeing this in the Go parser. Okay. So I guess we'll do full dec in range of parsed file dot declarations if okay underscore type deck is, oh god, how do you write this? Deck. Ooh, I can't remember. Golang cast to type cap coercions. There's an if, can't remember this. Oh yes, it's like yeah, okay. Type deck, okay, is the declaration times a pointer to AST dot type. What do we have? Expression statement, important send type spec. I don't know which one it would be. This one has function. And if you have struct, oh yeah. So we have struct here. Okay. Struct type. Oh, that's easy. What is this? Oh, yeah. And you can actually put this in an if statement. I just couldn't remember the syntax. But I'm trying to leave it like this actually. Wait, why? Yeah, I mean, maybe I'm looking at this wrong. Because I'm doing a parse file, right? Okay, this one does file gen field. It goes through the declarations. Oh wow, this does a ton of stuff, doesn't it? Type spec, and then it goes to AST gen declaration. What is gen declaration? Wow. Gen node, generic declaration that represents an import constant type of variable declaration. Okay. Now what do we have? We have right, I think. So if not okay, we continue. And here let's print type deck.token type. Yeah, that's right. Great. It should be typed because we're dealing with a struct, right? So it's like the test here. They did don't know what this is, but oh, because here it's getting a field name from a struct, right? It's going too deep, if anything. So it does the declarations, does the type spec, and then does dot type. Type deck dot type. Ooh, no. Type spec, yeah. Oh no, I'm one above. I'm on gen declaration, then I gotta do dot specs. Man, what are you? Specs. For underscore spec in range of type deck of specs. Spec dot, and then we kind of have to do the same thing here. It seems that struct struct deck and okay is spec as ast.struct type. Not yet, it seems. S dot type. No, come on. What do we have here? We go through the specs on S and we say, okay, are you a type spec? That's good. Type spec. If not, okay, continue. Struct declaration then. And then it goes s.type. ast.struct type. So this is going to be type spec struct type. Yeah. Struct type. And also an OK. If not OK, we continue. And then we have our struct. So we need to do a lot of type cohesion here. Oko has really nice syntax for this, so it's okay. So just kind of going back, because a lot of this is looking at the unit test they had here, or one of them. And we say from a file, a Go file, we take the declarations, all the declarations from this file, and we see if they're gen declarations. And this is a generic declaration node, which is an import, a constant, a type, or a variable. So stuff like function doesn't seem to get in here. We see that it is. If it's not, then we continue. Through them, we continue and make sure that type definition. I don't know why this here is an array. I don't quite understand what specs is. But maybe it's like the net. Struct.fields. Okay. So from the struct type, what we can extract is fields, if it's the end, the position of the token, position of struct keyword, field list, position of closing parenthesis. Okay, so it's going to be fields list. And this list has comments, type, documentation, position, tag, tag.kind. Okay, let's go through these. For underscore L in range of struct type dot fields dot list, and we'll just print L dot tag, L dot type, L dot okay, just for now. These, what do you give? Null and string. So the tag, field tag or null, actually. Type is string. Is there a name? Names. Why is it? Okay, for underscore name of range struct L dot names, I guess. Name dot name. Okay. I guess. It's kind of weird, it's an array. Isn't it? Do that print line. The length of L dot names. Just one. Okay, it's a good start then. So we have the name there. And actually, I'm going to get rid of you. I'm going to say if length of l.names is not equal to 1, then we're going to return this and errors.new more than one name returned. And then we go yeah, now we have to generate this stuff. Here we have field name, which is going to be l.names0, field name, field type, and this is where it could get confusing. Yeah, because this is a whole expression. This field type, I mean, field.type could be a million things, right? Yeah, it could definitely be so many things. Let's just print field name, field type. Okay, so we're gonna do a couple of things. You st indent name. Do you work? You probably work, right? Yeah. Yeah, and then type, because it's an expression, right? Because you can have stuff like much more complicated structs. Like you could have stuff like hello, and I think you could probably make your, you can definitely make your own, yeah, there you go, stuff like this. This is valid. This is one of the big edge cases we're gonna have to deal with in the future. Like a big, we can definitely do recursion for this type of stuff. But anyways, test-driven development, we must have a look at the first couple of ones. And we're gonna cast this to string. If not okay, then we return this errors.new field type was more complicated, not supported yet. And we can even do type. Oh, I can't really, can I? Really, ASD expression can't go to this? Oh, okay. So what can you go to? Oh yeah, it's basically it's an interface that implements node expression node. There you are. Which one of these is it? Indent. Is there a way to print a type? Golang print type of variable? Print type of variable? Can I do this somehow? Oh, I can. With HT, that's probably like really inefficient, but it would be nice to say fmt.printf field type t. What do you give me? AST indent. Okay, that is useful. Pointer to ident. I'm not sure what you're meant to be, to be fair. And then here I have name. Oh, identifier. That's that's so funny. If because .names is also identifiers. Yes, I get you. But there are also the edge case where you can have type struct and then embed another struct, for example, where we can just say another, and I think that'll be an identifier without a field type. But we'll deal with those later. If not okay, turn empty string and say errors.new field type was more complicated. Type t. Can I use formats? New. No, I can't. I guess not special. Ooh, not you. And this, delete to that. Okay. Okay. And now we have field name, string, and field type, which is nearly a string. If I do dot name, I can't. Type dent, and then field type, which is field type and dent dot name. There we go. Now we're all sorted. Great. Now what I have to do is, do I construct a map? I should, right? I construct a map of these. Or do I construct the strings I go along? No, definitely construct a map. Yeah, for sure. So up here, not even up there. The declarations here will just be 0 to start with, and then these are the fields. We can separate this into another function for sure. Okay. One thing we haven't asked for is the struct type name. Position struct keyword. So I mean, there's fields, there's position, there's struct. Can I get the name of the struct? Struct type once, twice, and 3 times there. Oh, it might be further above. It might be in the type spec node dot name. Right? Yeah, there we go. So that will give me the struct type. Simple struct. Perfect. Great. So down here, or even here, so we can kind of skip the OKs, we can go and ask for a map. Parse fields and types. That sucks. Parse map. Whatever. It's make of map between string and string. And yeah, string and string. And down here we say parse map at field name is equal to field type. Cool. And then after this full, let's just do struct name is type spec.name.name. Oh, not here. Yeah. Above, like on the top, struct list, which is going to be a map of maps. Map of string. And this goes to, no. String, that goes to map of string to string. Damn, that is some funky syntax. Wait, that's what the hell? You're not folding properly. Alright, whatever. We go struct list, which is really a struct map, because struct name equals parse map. Because it's here, the memory won't get freed, right? So I'm not going to get segfault here, because I'm defining parse map up here inside the scope, and I set it here, and then it goes outside the scope, and it doesn't get garbage collected because there's a reference here. Maybe I'm probably thinking about this too deeply, but we'll see. Maybe not. And then down here, we should have a list of stuff. So key value in the range of struct list. Let's just print the key. Simple struct, and then we go for key field, and then a type in the range v. And what are you? Field. What is this? What do you want? What are you on about? What? Expected one expression. Well, you have one expression, you silly. And then for a b in the range of v. I have no idea. Okay. Field type. There we go. Great. This gives me the intermediates, kind of. And let's just write the code here, and then we'll go on to separating some stuff, write some test cases, and yeah, continue. So output Valibot output, because right now we're shoving everything into the same function. It's really not great. We're mixing a lot of concerns, but we'll sort it. So to have Valibot, we would have Valibot output plus or equal to, it's going to be const plus the key, which is a struct name, and the v, which is the struct type, plus const struct name plus a space equals object. We're going to open parentheses, and we're not going to minify, we're trying to get nice output. And then new line. And for this, Valibot plus or equal to, we'll do even a tab to make things really nice. The field plus the field plus the colon there plus, this is where it's funky because it's going to be a type string. And actually for now I'm going to hardcode string. A hardcode string, do a comma. Ready for the other ones? Yeah, you can have trailing commas in JavaScript. So, and after you're all done with that, Valibot output plus or equal to, we're just going to do an equal here. Local Valibot output. And here we have to do a new line there, closing, a semicolon. And at the end we do Valibot output is plus or equal to we do new line plus local Valibot output plus another new line, maybe? Valibot output. Okay, I mean it's still failing. I think it's because we got the test wrong. If I do d dot log output parse, very nice. Const simple struct. Do you work now? Oh, it's probably because it of the new lines and stuff, right? Because it did new line, and it did that, and it did another new line. Is it that? Oh yeah, there we go. Perfect. Very nice. Okay. So that's chapter 1 done. The next thing we need to do is make the code nice, right? So this is messy and it wouldn't support multiple. So we have to separate it out into their own functions, so that really this should be single struct parse or something, you know? But yeah, okay, taking a break. And for you, I'll be back in a second. For me, I'll be back in a bit. All right, let's keep going. So we have one test case, and it works nice. Let's try another one. Func test simple struct, say 2, and test simple struct 1, and let's just get everything inside there. My simple struct is going to have not as simple. It's going to have a low, which is an int. It's going to have world, which is, say, int64, and lowercase a. That's a good thing. What do we do with lowercase? Should we not? Should we export them? I don't think so. I think we should keep them private, but I'll test that in another case. Let's say capital A, your string, capital B. So in JavaScript you have number, string, boolean. I think it's boolean, right? String boolean, you have object, null. Can you have nulls? I mean, yeah, you can have, yeah, of course. I think this should be okay for now. Okay, and the point is we're gonna have number, world is still a number, A, string, and B. Is it boolean? They have boolean, yeah. We have to sort out the imports as well of the stuff we use. Running the tests, one passes, one fails. So get rid of you. Hello string int64. Okay. So here we're gonna say, oh, how many types of int are there in Go? There's a few. Oh, I don't know how to. There's also floats, right? There's double, single. No. Maybe we just support int for now. No, but float. Golang. Oh, but there's definitely not a way of me doing that, is there? Field type is a string. I do wonder, field type identifier. Oh, there is exported actually. This will be useful. I think I might just have to do like if yeah, let's do func get JS type, go type string. Oh, error. Switch on go type. case int fall through. How many were there? X int is 8, 16, 32, 64. Int 8, 16, 32, and 64. There's also a float 32 and float 64, and this returns a number. We do case string. We return string. Nil return errors.new cannot find corresponding JS type. Okay. There's also bool. Oh, can't type today. Boolean and yeah, for now that's alright. And here we go. JS type get JS type, which is T. If error is not equal to null, return this and error. Plus this JS type plus a space plus the JS type plus, there you go, that's it. And yeah, I think that is kind of right. Okay, so we get not simple, number, string, boolean. That's right. Not as simple. Let's go. All right, so it all works. Okay. This is where we would make a commit to, but yeah. All right. Before we do anything else, we have two solid test cases. Let's write one more. And we go test simple struct 3 with more complicated types. So we go A, B, float 32, C, bool, D, string, E, string, and F, let's call it I. Simple but complex. F int 8. Let's just do all of them. A, C, D, E, F, G, H, I. 16, 32, 64, J, float 64, and then that should give us some really good test coverage. Complex. So here we have, this should be number, like this, like this, and like this. Simple but complex. Do you run? No, you don't run, but that all looks correct. Simple but complex. There we go. Oh, it's because of this. Oh no, it's not. What's wrong? So I have A as a number. Oh, E. Oh, they're not in order. Yeah. Yeah, they don't come in order. They're ordered by the parser in some weird way. But you know, I'm just going to copy this for now, and then we can sort that out later. No, that's it. Still failing. Oh, is it just random? That's... Oh wow, yeah, it is random. It's might be multi-threaded. Okay. I wonder why the top ones pass all the time then. Wait, do they pass all the time? Dot skip. Huh, maybe it's like beyond a certain number. It does some stuff. That's pretty weird. No, I'd love to maintain order though. Okay, let's skip this one for now. And let's organize our code. Or how do we skip? Oh, okay, let's not skip and make sure that they are put in the exact same order they were in. I think the way we can do this is by looking at the keys and sorting by the field type, the field name even. Oh, it's yeah. So we have struct name, and we have field and type. Yeah, we're gonna have to create like an array. But it's a stack array, so it will be okay. I think at least. We're gonna go ordered fields, which is gonna be oh no, it's not gonna be because it's not gonna be a thing. String, and it's gonna be the length of Golang get length of map. I guess it's just len. Okay. Times 2, because we're gonna like put the name, then the type, then the name, then the type. Cool. How do I sort things alphabetically in Go? Not just alphabetically, but oh, you know what? Just to simplify things a bit. Delete the ordered field names. Ordered. Oh, actually, let's make type name type struct is gonna have a name of string, type of string, and then we just do an array of those. Name type next string ordered fields. Great. And for each one, we're basically just going to go and say ordered fields index 0 that fields at index is equal to name type, where name is f and the type is the JS type, and then we do index plus plus, and we're gonna have to move this logic of putting it into string elsewhere. Okay. How do I sort things alphabetically? Golang, how to sort array of strings alphabetically. So they get the runes of the string, they go through each one, through each of the characters. Yep. So we do strings to lower. Alright, so then kind of creating a type. Yeah, I get it. That's okay. But even here, we want a list. We want to type name type list, which is an array of name type. Name type list, yeah. Name type list. Name type list. And here we do to be SI. It's a weird name. String. Oh yeah, I guess. And then here we do the name. Strings. I need to import you. Okay, that's not too bad. I think that's okay. And after all that is done, I can go autofills dot. Oh yes, hold on. Here I can do this dot less. Oh, sort. Yeah, right. I get you. Order. Is it order? Sort. And it's gonna be alpha. What did I call it? No, isn't it just so alphabetic list of strings. What? Oh, it's gonna be name type list dot ordered fields. Got you. Yeah. And then hopefully that works. Yeah. A bit cheeky, kind of stealing that from the internet, but I understand the code. It's pretty simple. You just iterate over a string. This does make the complexity of this pretty high, but you know, be alright. Could probably parallelize this, to be fair. Very. But then you run into the same issue you have to sort at the end, which is still faster, I think. But okay. It's definitely problems for the future. There we go. For field, and I should just underscore field range of ordered fields, field dot name. We take this plus or equal to the field dot name and then field dot type. Oh, wait, no, I don't want to sort. That's definitely not what I want to do. Oh, that's super annoying. I just realized because, I mean, if we sort, that's great, but it's not going to be the same as the original. Because it probably starts using some Go routines eventually. I think I have to sort, but not alphabetically. I have to sort based on, I have to sort up here. Fields. Yeah, I think this is it. L dot. Something about tokens here. Where is token? Tag dot position dot. What do you return? Token dot position. Oh, you're just an integer. Great. And what's no position 0? If 0 is no plus, there's no file enough. Okay. Okay, I think that's easier then. What I do is I do func of list, which is an AST dot. What was it there? Where am I even doing this? Fields dot list, which is AST dot field. And it's a is it less? Was it less that I had to implement? Less, length, and swap. Yeah, so I need to do these, which yeah, so that's used internally to. I'm implementing an interface here. That's great. And less takes in IJ boolean, not booleans, ints. They're the positions. Yeah, so we're gonna ask if it's less. Great. Now what we do is A, which is list at I, B, which is list at J, A dot position is less than B dot position. Return this. Invalid type. Is it? Isn't that what I got there? Here. Oh, it's an array of star AST field. Invalid receiver type. Bruh? Can I do bruh? No. Type, I don't know, sortable AST field, which is t.field. And here I can go sortable AST field. Bro, what the hell? Why can't I do this? What if it's that? Still no? Why? Oh, is it not an equals? It's just this. Oh, yeah, okay. Sort of AST field. Great. of name type. That's fine. No need for sort. Actually, yeah, you can go away. I don't need any of this. Don't need this. I don't even need this. I can just do this type. The hell? What did I do to JS type? No, what the hell happened to JS type? No, man. Did I actually get rid of it by accident? That's really annoying. Yeah, I might actually start using Git in a second. And I don't need you. Don't need you. Don't even need you anymore. Don't need you. I just need you there. F T. Oh no, it's just JS type. Don't need you. Yeah, and then the sorting happens further up the chain. No, I still need this. Fields, which is equal to sort. Oh, actually, just sort dot sort. Sortable AST fields of struct type dot fields dot list. It does not like that. Oh, because I didn't save that. Okay, let's start this top one. T dot. I can't just have this be the one, can I? Dash help. Go test. Slash help. Go test. I can't remember. To just run one of the things. Let's do t.skip. Let's do t.skip here. Okay, that one works. Does the second one work? Second one doesn't work. Because it goes world AB and then does hello. Bro, what? Is the position not quite what we want? Is it position? Yeah, maybe position is not. You know, like the actual field position, only like horizontal position. But that doesn't really make sense with what's going on here. Range struct this dot struct type dot fields dot list from T print line position print f position print what is it? I can't remember. X? No, P. I think it's that. Do that pause. Let's do t.fail now so that it actually fails. Oh, let's say fail here actually. Let's do t.skip up there. So it goes 44, 56, 70, 80. Is that the same every time? 44, 56, 70, 80. Hello world AB. Hello world AB. Should this be the other way around? No, I mean we got hello world AB, correct, and then the output is just different. Oh, is it? Oh, it's because maps. Oh, yeah, maps don't keep order. Maybe I've been overthinking this the whole time. Then it's about maps. It's not about. Oh, that's. I think that sucks. It's maps. It's not the fact it doesn't come sorted. Oh, I am silly. I know the problem now. And it is nothing to do with sorting. It's because of maps. Maps aren't guaranteed to keep position. Of course they're not. Because that would be weird. You can go. Basically all of this can go. Okay. Great. So I guess we're going to do parse map, not a string, but we can make, yeah, we can just make that struct type. I said type name type struct, just name string type string, and you're going to be an array of name type. Let's do 0 for now, and then append as we go along. Parse map is append name type, name, field name, type, field type. There we go. And then with structs, I think for now we can keep it as a map, but eventually we won't want to. Yeah, we don't really want a map anyways, like, because we're gonna read it once, and the whole thing of maps is that they have quick-ish reads, not very fast reads. But they have very fast inserts, and we're inserting a lot. Okay. Anyway, it's going to be a map of string to an array of name type for now. Did that fix you? T.type. And it's going to be f is an int. Oh, field type. Field type dot type. Field type dot name. Okay. And now I can skip. I can delete the skip. I can get rid of the fill now. I can get rid of you. There we go. They all pass. Nice. And let's go. Git init git add dot git commit feat initial tests for basic struct to Valibot parser. Git. Let's do GitHub repo create struct types. This. Go valid. Go to TS Validator. That's a terrible name. But anyways. Get remote add origin, go to ts validator, git push dash dash, oh, did I just get push? Dash dash set upstream origin main. There we go. We have our initial thing there. Okay. I'm going to stop this video for now because we've done a lot and we have some of the logic already done. Oh no, actually before I finish the video, I have 3 test cases, and what I'm going to do is I'm going to tidy up the code. Right, so I'm going to have test cases on the right, and I'm going to tidy up the code a ton. So ideally we should have a function that parses, and we should have a function that that takes the struct to Valibot, and then eventually we could implement others that would be like, you know, struct to Zod or something. You can do whatever you want there, and this is going to take an array name type, and this is going to output a string of error. And basically the logic here is the logic down here. So we have Valibot input from name type struct list. Oh no, type struct list, which is going to be a map of string to an array of name type to struct list, and here I can actually do struct list. Perfect, 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 and it goes return Valibot output. There we go. Great, struct Valibot. Valibot output error struct to Valibot struct list. If error is not equal to null, we return this and the error. Let's do this. Running. Okay, test pass. 1 refactor done. Next is this here, which is going to be struct list struct ast2 list, which is going to be ast structs. It's going to be dot ast dot field. I think it was. Yeah, field. There we go. And it returns this returns an array of name type, an error. And basically, all that is this here. Field struct fields. Actually, struct fields. Change to that. ast structs. Return struct fields. Struct fields. Struct fields. Down here we're gonna go return struct fields and nil. Okay, struct fields is get struct, what did I call it? Struct ast to list, which is gonna be my struct type dot fields dot list. It's gonna be an error. If error is not equal to null, we return this and error. Struct fields. Perfect. Okay, now code is a little bit tidier. Our tests still run. Wikifactor, shifting, extracting logic to separate functions. Now, last thing with Valibot is that the output is not quite valid. The reason is we need an import, and it's going to be on that top line. Actually, let's make it on the second line. It's fine. Import object number. To be fair, this is probably where we would want to add some sorting. Object. Let's just go with as they come. String boolean. Doesn't actually matter, right? From Valibot. Semicolon, go down. Same for this. Import object, just a string, and there we are. So first of all, I'm going to start with that top one. I'm going to skip this test. I'm going to skip this test, but whilst I'm here, I am going to add the line. It's going to be object number, boolean string, and that's it. Now my tests fail. Shift to Valibot, and in here in the Valibot function, we can have the import line, right? And the import line, so I mean it will start like, I'm going to say object comma, because we're always going to import object first. And then, actually, oh yes, imported validators. It's going to be make of string array 0. And this is not going to be super efficient because we're going to have to do a linear search through the array to see if it has. But a map would give us stuff out of order, and the size of the array is always going to be super small. So, one of the things we could do straight away: import validators equal append object, because we're going to have object. Slices dot includes. Oh, what do we have? Index functionally compare binary is sorted. Sort max min grow clone equals index. Yeah. In imported validators of the JS type exists. It's not equal to -1, right? That's what it said. This one's -1. Okay. If doesn't exist, then we do imported validators yes type. And then what we could do is we could do new line plus import line this for underscore validator in the range of imported validators, import line plus or equal to validator plus comma space, and then we go imported line equals imported line length of import line -2, because we want to remove that one on the very last thing. Then we do a new line starter plus the import line plus new line plus Valibot output. And that fails, that fails. I want t.log output parse. Oh, yes. Import line is equal to import curly braces this plus that plus close curly braces from Valibot this semicolon new line. And I don't even need that now. Object and string. Validbot, nice. Great. Second test also passes. This one also passes. Really good. We have some really good, well, really good. It's kind of a strong word. We have solid output code. It's pretty cool. Some takeaways from this video so far is that the library is nice. The AST parsing library that Go actually is using. It's quite funny using to parse this the file to actually run the file in the test, and then yeah, it's good that they expose it. Actually, I would expect some languages to, you know, maybe not expose it, I guess. I'm not sure. But cool, we have some very nice imperative code. We'll continue to work to make it to have multiple structs, but for now, pretty cool. Feet, import line depending on required validators. There we go. Right. If you sat through this far, thank you so much for watching, and I'll catch you in the next chapter where I'll continue. Alright, take care.